How does the magnetosphere help animal behavior on Earth?
Earth's magnetic field is also very important to animals on Earth that migrate or otherwise travel long distances. Some animals have impressive built-in magnetic sensors. Biologists have shown that many migratory birds figure out where to fly by using Earth's magnetic field to guide them. Humans, too, benefit from the magnetosphere by using magnetic compasses to figure out which way is north or south.
What are the four major cloud groups and their types?
Clouds are categorized in the following manner. 1. High clouds are composed almost entirely of ice crystals. The bases of these clouds start at 16,500 feet, 5,000 meters, and reach up to 45,000 feet, 13,650 meters. A. Cirrus clouds, from the Latin for lock of hair, are thin, feathery crystal clouds that appear in patches or narrow bands. B. Cirrostratus clouds are thin, white clouds that resemble veils or sheets. These clouds can be striated or fibrous in appearance. Because of the ice content, they are associated with the halos that surround the sun or moon. C. Cirrocumulus clouds are thin clouds that appear as small white flakes or cottony patches. They may contain supercooled water. 2. Middle clouds are composed primarily of water. The height of the cloud bases range from 6,500 to 23,000 feet, 2,000 to 7,000 meters. A. Altostratus clouds appear as bluish or grayish veils or layers of clouds that can gradually merge into altocumulus clouds. The sun may be dimly visible through them, but flat, thick sheets of these clouds can obscure the Sunday B. Altocumulus clouds are white or gray and occur in layers or patches of solid clouds with rounded shapes. 3. Low clouds are composed almost entirely of water and may at times be supercooled. At subfreezing temperatures, snow and ice crystals may be present as well. The bases of these clouds start near Earth's surface and climb to 6,500 feet, 2,000 meters. In the middle latitudes, A. Stratus clouds are gray, uniform, sheet-like clouds with a relatively low base, but they can also be patchy, shapeless, low gray clouds. Sometimes thin enough for the sun to shine through, these clouds bring drizzle and snow. B. Stratocumulus clouds are globular, rounded masses that form at the top of the layer. C. Nimbostratus clouds are gray or dark, relatively shapeless, massive clouds that contain rain, snow, and ice pellets. 4. Clouds with vertical development contain supercooled water above the freezing level and grow to great heights. The cloud bases range from 1,000 feet, 300 meters, to 10,000 feet, 3,300 meters. A. Cumulus clouds are detached, fair weather clouds with relatively flat bases and dome-shaped tops. These usually do not have extensive vertical development and do not produce precipitation. B. Cumulonimbus clouds are unstable, large. Vertical clouds with dense boiling tops that bring showers, hail, thunder, and lightning.
What was Snowball Earth?
Scientists now believe that at between 2 to 4 times between 850 and 580 million years ago, the planet was covered completely in ice and early life forms were nearly wiped out, a snowball Earth. There are a couple of theories as to why this occurred. One being that the Sun was about 6% cooler than it is today, the other is that the continents had all traveled due to plate tectonics mostly south. Ocean currents traveled easily around the planet without interruption, and volcanic activity dwindled to a minimum. The result was that significantly less carbon dioxide was being generated and expelled into the atmosphere. In addition, the Earth's axis was significantly more tilted at the time, by 54 degrees versus today's 23.5 degrees, causing more drastic seasonal extremes. Once a period of cooling began and ice shelves formed, more of the sun's light was reflected, thus causing the cooling cycle to accelerate more and more until everything was frozen. Early theories about this, proposed by such scientists as George Williams at the University of Adelaide and Joe Kirschvink at the California Institute of Technology, include the effects of plate tectonics as causing massive volcanic eruptions worldwide. This would lead to an extended winter of unprecedented scale that turned Earth into one big frozen lump in space that would last for millions of years. Nearly all life was wiped out. In fact, one matter of debate concerning this theory was that critics felt such a snowball Earth would have extinguished all life. This notion was laid to rest in the 1990s when life was found to thrive near geothermal vents deep under the ocean. The snowball Earth cycle was only broken because volcanic action and plate tectonics would cause carbon dioxide levels to build under the ice, especially since there would be no liquid water to dissolve minerals or aid in the dissipation of CO2 levels. The result would be an inevitable, sudden massive release of CO2 that would lead to a comparatively brief period of extreme heat with temperatures averaging 120 degrees Fahrenheit 50 degrees Celsius. However, the thaw retreated to another snowball period a couple more times over millions of years, before the continents moved into positions that created a more stable geophysical state of the planet. Volcanic activity moderated, as did carbon dioxide levels. Another snowball Earth could happen again, however, as the continents, hundreds of millions of years from now, drift back together to form a new supercontinent.
Is Yellowstone actually a supervolcano?
Yellowstone National Park is renowned for its scenic geysers and hot springs covering some 2,300 square miles, 3,800 square kilometers. The energy for all this hot water actually comes from volcanic Energy below a plateau that is actually a giant caldera. Geologists estimate that this massive volcano last erupted about 640,000 years ago with an energy equal to 8,000 Mount St. Helens eruptions. One can only imagine the destruction such an explosion would have wreaked. A nuclear winter would have ensued, acid rain would have fallen from the sky. And some scientists believe that the human race was driven almost to extinction at the time. Since the volcano is still active, it could happen again at almost any time. Some parts of Yellowstone have risen about 29 inches, 74 centimeters. Since measurements were first taken in 1923, which indicates a buildup of magma beneath the crust. It is only a matter of time before this energy is released. And Yellowstone is not the only such supervolcano. The last such eruption came from Toba, Sumatra. About 70,000 to 75,000 years ago, and other, as yet undiscovered supervolcanoes might exist.
Do lakes have tides?
Compared to oceans and seas, lakes generally do not contain enough water to have noticeable tides due to the gravitational effects of the moon on the Earth. They do have tides, though, and large lakes, such as Lake Superior in North America, are big enough to have observable tides. Lake Superior's waters fluctuate about 3 inches.
How much time does it take for sunlight to reach the Earth?
The speed of light is about 186,000 miles, 300,000 kilometers, per second, and the Sun is about 92.58 million miles. 149 million kilometers, away, so it takes sunlight 8.4 minutes to reach our planet. Therefore, the Sun we see in the sky is actually as the star appeared over 8 minutes ago. Not to paint too depressing a picture, but if the Sun went nova, no one on Earth would realize the end was near for 8.5 minutes.
How fast does rain fall?
The speed of rainfall varies with drop size, wind speed, and the size of the raindrops. A typical raindrop in still air falls about 7 miles, 11 kilometers, per hour. Large raindrops can reach speeds of 16 to 20 miles, 26 to 32 kilometers, per hour. While the tiniest drops are slower than a mile, 1.6 kilometers, per hour as they drift to Earth. Thus, the larger drops can usually splash onto the ground about 3 minutes after being generated in a rain cloud that is about 5,000 feet, 1,500 meters, above the surface.
What are solstices and when do they occur?
A solstice is a time of the year when Earth is pointed either the closest toward the sun or the farthest away from it. On the summer solstice, there are more minutes of daylight than there are on any other day of the year. On the winter solstice, there are fewer minutes of daylight than there are on any other day of the year. In the northern hemisphere, the summer solstice occurs around June 21st of each year. When the North Pole is pointed closest toward the sun, and the winter solstice occurs around December 21st of each year. When the North Pole is pointed farthest away from the sun.
Are tornadoes often formed in hurricanes?
It is fairly common for tropical storms and hurricanes to generate tornado activity. And sometimes several tornadoes touch down in a single storm. One of the best examples of this was 1967's Hurricane Beulah, during which 115 tornadoes were seen. In 2004, Hurricane Francis generated 123 tornadoes, the most ever recorded.
What is latent heat?
The concept of latent heat was discovered by Scottish chemist Joseph Black, 1728 to 1799, as well as independently, by Swiss meteorologist, geologist, and physicist Jean-André Deluc, 1727 to 1817. When water condenses, cools, or freezes, it loses energy and, thus, gives off heat. Water condensing into vapor releases an amount of energy equal to 600 calories per gram of water. When water freezes, it releases about 80 calories per gram. The heat released provides energy for storms to form.
How is asthma related to air pollution levels?
Asthma is rapidly becoming one of the major health issues in the United States, especially for children living in cities. A study released by the National Institute of Allergy and Infectious Diseases in 2008 showed that asthma particularly affected children in poor, inner-city areas, and that car emissions of nitrogen dioxide, as well as air particulates and sulfur dioxide, were to blame. The study evaluated over 800 children in 7 urban areas. These children had significantly higher rates of asthma and decreased lung function, which contributed to poor health and school absenteeism, even when the level of pollutants in the areas where they lived was deemed to be lower than acceptable standards set by the Environmental Protection Agency. Other studies have also shown that children have more allergies when they have been exposed to higher levels of air pollution.
Is global warming causing deserts to expand?
Desertification. The expansion of deserts and corresponding decrease in fresh water supplies is the result of several factors, including agricultural misuse, overpopulation, drought, and also climate change. There is no question whatsoever that the world's deserts are increasing in acreage at an alarming rate, and that freshwater lakes and other water supplies are shrinking and turning to dust. Many examples may be cited, but here are just a few. Lake Chad, which has water shared by the African nations of Nigeria, Niger, Cameroon, and Chad, is 95% smaller than it was in the 1960s. Kazakhstan has lost half of its productive farmland since 1980. Sandstorms in Iran have engulfed more than 100 villages since 2002. The Gobi Desert in China is growing quickly, destroying land and causing giant dust storms that cost the country $6.5 billion every year. It is estimated that, by 2025, 3/4 of Africa will face starvation because of the loss of water and farmland. Population migration and fights over resources are leading to wars, especially in Africa, such as the current conflict in Sudan.
How tall can thunderstorm clouds be?
Even a fairly average thunderstorm has a height of more than 20,000 feet, 6,000 meters. With the tallest storms being reported at over 70,000 feet, 21,000 meters.
Do all scientists agree that global warming is caused by human beings?
In short, no, not every scientist believes people create global warming. Although more and more scientists are becoming convinced that we are seeing a significant change in our climate, there are those who argue that it has more to do with solar cycles. Some meteorologists have also noted that, historically, climate warming has preceded increases in carbon dioxide levels, not the other way around. This is because when the Earth warms up, it also warms the oceans, which hold much of the world's carbon dioxide in the form of carbonic acid. When the oceans get warm enough, the carbon dioxide is then released into the atmosphere.
Who invented the dew point hygrometer?
The dew point hygrometer, a type of dry and wet bulb psychrometer, was invented in 1820 by John Frederick Daniel, 1790 to 1845. It consisted of two thin glass bulbs joined by a glass tube. One bulb held a thermometer and was filled with ether, the other was empty. As the air in the empty bulb cooled, the ether would condense on the thermometer, indicating the dew point temperature. Variations of Daniel's device are still used today, including cooled mirror hygrometers that measure dew point when condensation forms on a mirror.
What are cosmic rays?
Cosmic rays are invisible, high-energy particles that constantly bombard Earth from all directions. Most cosmic rays are protons moving at extremely high speeds. But they can be atomic nuclei of any known element. They enter Earth's atmosphere at velocities of 90% the speed of light or more.
Why do meteorologists refer to the Reynolds number when talking about turbulence?
The Reynolds number is a mathematical result computed by calculating the ratio of inertial to viscous forces. Put in more understandable English, it measures how fluids move through an area of defined diameter. It is named after English physicist and engineer Osborne Reynolds, 1842 to 1912, who was interested in how water flows through rivers and in waves and tides. However, it can also be used in terms of air flowing through the atmosphere, and thus has applications in meteorology, where Reynolds's formula is used to calculate air turbulence.
What is more dangerous, a big tornado with a funnel spanning over a mile in diameter? Or a narrow, speedy tornado?
Either one can be equally dangerous. Many factors are involved when considering how lethal and destructive a tornado may be, including how fast the vortex is spinning and how much debris is being blown around.
How does the wind chill factor affect temperature?
Also known as the wind chill index. It is a number that expresses the cooling effect of moving air at different temperatures. The National Weather Service began reporting the equivalent wind chill temperature, along with the actual air temperature, in 1973. For years it was believed that the index overestimated the wind's cooling effect on the skin. A new wind chill index was thus instituted in 2001, and other adjustments have since been made, too.
What causes avalanches?
The most dangerous conditions for an avalanche occur when a lot of snow has fallen and slash or blowing. Wind has caused snow to accumulate within a short period of time, hours or a few days, versus weeks. A dry slab avalanche is the most hazardous. This is when a heavy slab of snow that has formed quickly is resting above another layer of snow that is weaker but formed over a longer period of time. Dry slab avalanches are usually set off by a person walking over the unstable layer. There are also wet slab avalanches, which, as one might guess, involve a layer of wet snow over a harder layer of snow. Avalanches are most likely to occur on hills with inclines of 30 to 45 degrees. Though wet snow can tumble down a hill with a grade of as little as 10 degrees. And dry snow regularly causes avalanches on hills with about 20 to 22 degree slopes. Avalanches happen abruptly, and once a slab has broken off. There is usually no escape for someone downhill. Traveling at 60 to 80 miles, 95 to 130 kilometers per hour, an avalanche will quickly bury everything in its path.
When was the first official storm warning issued in the United States?
Professor Increase Lapham, working with the U.S. Signal Corps, issued the first severe storm warning in America on November 8. 1870. The warning concerned a storm that was building strength in the Great Lakes.
What is the moist tongue?
Sometimes meteorologists come up with some pretty fanciful descriptive terms. Moist tongue falls into that category. It refers to humid tropical air moving in the direction of either the North or South Pole. A moist tongue regularly occurs in the spring and summer over the U.S. Central Plains, where it works in conjunction with a jet stream to produce storms.
How did Earth's atmosphere form?
Some of Earth's atmosphere was probably gas captured from the solar nebula 4.5 billion years ago, when our planet was forming. It is thought that most of Earth's atmosphere was trapped beneath Earth's surface, escaping through volcanic eruptions and other crustal cracks and fissures. Water vapor was the most plentiful gas to spew out, and it condensed to form the oceans, lakes, and other surface water. Carbon dioxide was probably the next most plentiful gas, and much of it dissolved in the water or combined chemically with rocks on the surface. Nitrogen came out in smaller amounts, but did not undergo significant condensation or chemical reactions. This is why scientists think it is the most abundant gas in our atmosphere. The high concentration of oxygen in our atmosphere is very unusual for planets, because oxygen is highly reactive and combines easily with other elements. In order to maintain oxygen in gaseous form, it must constantly be replenished.
When were huge snowflakes observed?
In January 28, 1887, in Ft. Kia, Montana, there was a snowfall that included flakes measuring a spectacular 15 inches. 38.1 centimeters, across. Of course, these flakes were not individual crystals, but rather clumps of crystals sticking together to form large flakes. Not long after these stunning flakes were seen, Shire Newton, England, experienced a storm in 1888 where 3.75-inch, 9.5 centimeter, snowflakes were seen.
How is the ionosphere important in the transmission of radio waves?
When ultraviolet light enters the atmosphere, it ionizes atoms in the ionosphere through a process called photoionization, which releases free electrons into this region of the atmosphere. It is these free electrons that make radio wave transmissions possible. Depending on the frequency of the radio waves, transmissions travel for shorter or longer distances. Lower frequency waves bounce off the ionosphere at a lower elevation, and thus travel a shorter distance than higher frequency waves. Very high frequency waves are used when communicating with satellites or anything out in space because they can completely escape the atmosphere. British physicist Oliver Heaviside, 1850 to 1925, and American electrical engineer Arthur Edwin Kennelly, 1861 to 1939, independently theorized the existence of an ionosphere, and that certain wave frequencies would bounce off it and be reflected back to Earth. It was radio pioneer Guglielmo Marconi, 1874 to 1937, who first took advantage of this theory. To conduct the first transmission from Cornwall, England, to Newfoundland in 1901. The waves became known as radio waves, and Marconi is credited as the inventor of the radio. The E region of the ionosphere was named after Kennelly and Heaviside to honor their work.
What did Benjamin Franklin contribute to the science of meteorology?
Benjamin Franklin, 1706 to 1790, who is said to have discovered electricity by flying a kite in a storm and who later invented the lightning rod, made the important discovery that low-pressure systems caused the atmosphere to circulate in a rotating pattern. He made this discovery in 1743, after unsuccessfully attempting to view an eclipse on October 21. There was a storm in Philadelphia at the time, but he later learned that the skies were clear in Boston that day. Of course, he wasn't able to take an airplane to Massachusetts. But what he did find out the next day was that the storm that had been in Philadelphia had traveled to Boston. From this information, he surmised that the storm was traveling in a clockwise manner from southwest to northeast. Putting two and two together, Franklin concluded that the low-pressure system was causing the storm to move in this manner.
How much air pollution does the United States produce?
According to the Environmental Protection Agency, there is some good news in that air pollution has been slowly declining in the United States. For example, carbon monoxide emissions have gone down from 178 million tons, 161.5 metric tons. In 1980 to 81 million tons, 73.5 million metric tons, in 2007. Volatile organic compounds, VOX, and sulfur dioxide have both been cut in half, from 30 to 15 million tons 27.2 to 13.6 metric tons. For VOX and 26 down to 13 million tons 23.6 to 11.8 metric tons for SO2, over the same time period. And nitrogen oxides have been lowered from 27 to 17 million tons, 24.5 to 15.4 metric tons. Overall, from 1980 to 2007, air pollutant rates have dropped from 267 million tons, 242 metric tons, produced annually to 129 million tons, 117 metric tons. This is still a lot of pollution, without question, but it is significant progress. Especially considering that the US population has risen from about 226 million people in 1980 to 300 million in 2007.
Did a tornado almost change music history?
If you notice the listings of cities in the deadliest U.S. tornadoes table, you may have caught the fact that the fourth listing was Tupelo, Mississippi, the hometown of Elvis Presley, 1935 to 1977. Elvis was just an infant at the time, and he fortunately survived the funnel cloud that killed over 200 people on April 5, 1936.
How unhealthy is snow shoveling?
Heart attack rates increase sharply during the winter months in northern climates. Because people who are older or are not very healthy get too much exercise shoveling snow. Because more men than women tend to shovel snow. About 3/4 of winter fatalities after snowstorms are men. 50% of these men, too, are over 60 years of age.
What is SODAR?
If LiDAR is light radar, then you can probably guess that SODAR is sound radar. SODAR stands for sound detection and ranging. It is different from sonar in that sonar uses sound waves traveling through water, whereas SODAR is detecting the reflection of sound waves through the air. By calculating the Doppler shift of sound waves, SODAR can be used for evaluating wind speeds and direction, as well as temperature inversions and other types of turbulence.
What is the Vortex project?
Vortex stands for verification of the origin of rotation in tornadoes experiment. Conducted at the National Severe Storms Laboratory from 1994 to 1995, the project was led by Erik Rasmussen. And the goal was to conduct intense data gathering using weather balloons, airplanes, turtles, and cars equipped with radars and taking photographs. The study focused on tornadoes formed in supercells and collected so much data that it took years to analyze it all.
How much pollution is generated by airplanes?
At any given moment in time, there are about 5,000 non-military aircraft flying the skies over the United States. It takes a tremendous amount of fuel to keep all these transports aloft. And the burned fuel results in exhaust similar to that coming from car engines, nitrogen oxides, sulfur dioxide, carbon monoxide, and soot. In addition, water vapors are released, which form ice crystals at high elevations commonly called contrails. Meteorologists believe that these contrails increase the formation of cirrus clouds, which may contribute to global warming.
What is indoor humidity?
Because we now live in homes with environments controlled by air conditioning, furnaces, and fans, the humidity inside is often very different from what the weather is like outside. For instance, in the winter many homes are very dry inside, which increases static electricity and causes uncomfortably dry skin. Overly humid air within a home can lead to the development of mold and mildew, some of which can be a risk to your health. Also, air that is too dry or too moist can cause structural damage to a house. Overly moist wood, too, encourages pests such as termites to chew wooden supports and flooring.
Does the air have tides?
Strangely enough, yes. Just as with water, the atmosphere can be affected by the moon's tug on the Earth, so that air pressure can change in air masses daily. The changes are very small, though about 1 or 2 millibars an. These changes are mostly seen only in equatorial zones.
How much of the Earth was covered in ice during the various ice ages?
Because of extensive erosion, it is difficult to determine the extent of ice sheets during the various ice ages. But scientists do know some things about the last ice age, the Pleistocene Ice Age, a time when up to 10% of the Earth was covered, although not simultaneously, by often miles-high ice. At their greatest extent, the Northern Hemisphere glaciers and ice sheets covered most of Canada. All of New England, much of the upper Midwest, large areas of Alaska. Most of Greenland, Iceland, Svalbard, and other Arctic islands, Scandinavia. Much of Great Britain and Ireland, and the northwestern part of the former Soviet Union. In the southern hemisphere, glaciers were much smaller, with the main effects being cooler and much drier weather. During the last stage of the Ice Age, the Wisconsin stage in the United States, ice sheets covered parts of Eurasia and much of North America, extending as far south as Pennsylvania. As the climate warmed up, scientists estimate that sea level rose about 410 feet. 125 meters, an average rate of an inch, 2.5 centimeters, per year for roughly 5,000 years. Interestingly, although most of the huge northern ice sheets melted, the Antarctic ice sheet decreased by only 10%.
Where is the most humid place on Earth?
In terms of highest dew point temperatures, the extreme is found along the coast of Ethiopia along the Red Sea. Here, the average afternoon dew point in the month of June is a staggering 84 degrees Fahrenheit, 28.9 degrees Celsius. Tropical rainforests the world over, of course, are known for extremely high humidity.
What is barometric pressure and what does it mean?
Barometric, or atmospheric, pressure is the force exerted on a surface by the weight of the air above that surface, as measured by an instrument called a barometer. Pressure is greater at lower levels because the air's molecules are squeezed under the weight of the air above. So while the average air pressure at sea level is 14.7 pounds per square inch, at 1,000 feet, 304 meters, above sea level, the pressure drops to 14.1 pounds per square inch. And at 18,000 feet, 5,486 meters, the pressure is 7.3 pounds, about half of the figure at sea level. Changes in air pressure bring weather changes. High pressure areas bring clear skies and fair weather, low pressure areas bring wet or stormy weather. Areas of very low pressure have serious storms, such as hurricanes.
What does the American Meteorological Society, AMS, do?
The AMS is an organization of professionals, as well as amateurs, in the field of meteorology and atmospheric and oceanic sciences that is intended to foster communication, promote education, and share resources. Those without formal degrees in the field can still be members with the rank of associate. And a student membership level is also available to those still in school. The Society, headquartered in Boston, Massachusetts, publishes periodicals and books. Awards accomplishments in the field, and sponsors conferences and the Seal of Approval program.
What is the jet stream?
The jet stream is a band of swiftly moving air located high in the atmosphere, and affects the movement of storms and air masses closer to the ground. The currents of air flow from west to east and are usually a few miles deep. Up to 100 miles, 160 kilometers, wide, and well over 1,000 miles, 1,600 kilometers, in length. The speed at which the air travels in the jet stream is over 57.5 miles, 92 kilometers per hour, sometimes moving as fast as 230 miles, 386 kilometers per hour. There are two polar jet streams, one in each hemisphere. The jet streams meander across the troposphere and stratosphere. Up to 30 miles 48 kilometers high, and between 30 and 70 degrees latitude. There are also two subtropical jet streams, one in each hemisphere, that range between 20 and 50 degrees latitude. The subtropical streams flow between altitudes of 30,000 to 45,000 feet, 9,150 to 13,700 meters, and are even swifter than the polar streams, moving at speeds of over 345 miles, 550 kilometers, per hour.
What is the difference between the ecliptic plane and Earth's equatorial plane?
The equatorial plane is the plane of Earth's equator extended indefinitely out into space. It turns out that Earth's rotation around its axis is not lined up with the ecliptic plane. Instead, Earth is tilted about 23.5 degrees. This tilt is the main cause of the seasons on Earth.
Is it possible to get frostbite in Hawaii?
Sure. Stand on top of Mount Haleakala on the island of Maui, or Mauna Kea on the Big Island. In the winter, or even spring or summer, and you can easily be exposed to temperatures well below -20 degrees Fahrenheit. -29 degrees Celsius, for a long enough time to develop frostbite.
Is it ever too cold to snow?
No matter how cold the air gets, it still contains some moisture. And this can fall out of the air in the form of very small snow crystals. Very cold air is associated with no snow because it is usually very dry, and these invasions of air from northerly latitudes are associated with clearing conditions behind cold fronts. Heavy snowfalls are associated with relatively mild air in advance of a warm front or on the backside of a strong low-pressure system. The fact that snow piles up, year after year, in Arctic regions illustrates that it is never too cold to snow.
Has there ever been an F6 tornado?
No. Although the old Fujita scale did allow for an F6 tornado, estimating that winds up to 380 miles. 611 kilometers per hour were theoretically possible, there has been no recorded tornado of that intensity. The EFS does not include an F6 category at all, and lists any tornado with winds over 200 miles, 320 kilometers per hour as an F5.
How hard is it to become a meteorologist who is a radio or television broadcaster?
If your goal is to specifically become a television weatherman or weatherwoman, then, ideally, you need to combine training in meteorology with education in communications and/or the broadcast arts. You should be comfortable appearing on camera. And it helps if you have completed an internship in broadcasting while in school. As with anyone who wishes to pursue a television or radio career, you will have to sell yourself as an appealing on-air personality. Prepare professional demo tapes of yourself doing a broadcast and send these to news directors at the stations for which you wish to work. You should prepare yourself to start at the bottom of the career ladder, which means working shifts in the very early morning or very late evening hours, as well as working for low pay in a town or city that has a small market. Don't expect to work right away for a big network in New York City or Los Angeles. It could be years before you manage to get a job in a big market. And in the meantime you will likely move frequently while you search for better and better opportunities. Today's media world is especially challenging, as stations and newspapers across the United States are cutting their budgets and centralizing operations. Weather broadcasting is probably the hardest specialty to get into these days. And many other fields within meteorology offer better opportunities.
What is air pollution?
Air pollution is caused by many sources. There are natural pollutants that have been around as long as the Earth, such as dust, smoke, volcanic ash, and pollens. Humans have added to air pollution with chemicals and particulates. Due to combustion and industrial activity, anthropogenic sources.
What are cooperative weather observers?
While the U.S. government funds many weather stations throughout the country, The cost of supporting all of the stations that would be necessary to fully observe the weather everywhere would be prohibitive. Thankfully, volunteers known as cooperative weather observers assist by taking readings and measurements about winds, temperatures, precipitation, and so forth. Providing this data to meteorologists in cooperation with the National Weather Service and the National Climatic Data Center.
Is Earth's atmosphere changing?
Earth's atmosphere is continually and gradually changing. Over cycles that usually last many thousands of years. The concentrations of different gases including oxygen, carbon dioxide, and others go up and down, as does the concentrations of tiny dust particulates such as carbon soot. In the past 100 years or so, human population growth and industrial activity has caused a much sharper change in the concentrations of some gases and particulates on a much shorter time scale than at any time in the past 200,000 years. The most dramatic effect has been a huge increase in the amount of carbon dioxide in the atmosphere. This increase has created a substantial greenhouse effect. According to some scientists, which could be increasing the average temperature on Earth at a much faster rate than typical ecological and geological time scales.
What is emergency response planning?
Most disasters in the United States, about 85%, occur because of the weather, with the rest due to such geologic events as volcanic eruptions and earthquakes, or acts of terrorism. In an effort to minimize the costs of such tragedies, a system connecting federal, state, and local agencies has been established to issue weather warnings, plan evacuation routes, and coordinate relief efforts. Community awareness programs, building code enforcement, and computer modeling are all employed in this effort, with meteorologists naturally playing a key role.
What is a slough?
A slough is a layer of loose snow. On rare occasions, an avalanche may be comprised of slough rolling down a hill. But more frequently it is a dry or wet slab that causes an avalanche.
What is the difference between snow and hail?
Snow is water vapor that freezes in clouds before falling to the earth. Hail is water droplets, raindrops, that have turned to ice in clouds.
Does the sun emit a constant amount of energy?
The energy the sun emits technically called solar irradiance currently is much more than it did when the solar system was young. Scientists estimate that, billions of years ago, our sun only emitted about 75% of the energy it now does. Now, however, the amount of solar irradiance is fairly stable, though not completely constant. It can vary by as much as 0.1%, which may not sound like much. But such fluctuations are big enough to make the difference between moderate and frigid winters, merely warm or searing hot summers. Solar irradiance can be affected by sunspots, but the internal workings of the sun are still so complex that scientists do not fully understand what causes these fluctuations. Despite there being no complete consistency in the sun's energy output, astronomers and meteorologists still refer to a solar constant, which is the amount of energy of all emissions, measured in watts per square meter. Readings are taken at the upper extremes of the Earth's atmosphere, which receives, on average, about 1,366 W/m².
What are the sources of air pollution?
Air pollution can be in the form of either a gas or an aerosol. And it can either be anthropogenic, man-made, or natural. Man-made sources of pollution include factories, cars, motorcycles, ships, incinerators, wood and coal burning, oil refining, chemicals, consumer product emissions like aerosol sprays and fumes from paint, methane from garbage in landfills, and pollution from nuclear and biological weapons production and testing.
What were the glacial and interglacial periods in the last ice age?
In the last ice age, and in all ice ages, there were cycles of glacial, when ice covered the land, and interglacial, relatively warmer temperatures, times. Corresponding with these times, the glaciers advanced or retreated. Scientists believe the last ice age, also called the Pleistocene Ice Age, had 8 cycles. The following lists these stages for North America. Stage names for Northern and Central Europe differ.
What was the first university to offer a degree in meteorology in the United States?
The Massachusetts Institute of Technology was the first institute of higher education to offer a meteorology degree. Swedish meteorologist Carl Gustav Rossby, 1898 to 1957, founded the program there in 1928. Rossby would go on to found programs at the University of California at Los Angeles and the University of Chicago, as well.
What is a bolide?
Bolides are meteors large enough to create an easily seen fireball as they enter Earth's atmosphere. They can even be seen during the daytime and often appear greenish, though other hues have also been observed.
Am I getting hit by neutrinos right now?
You and every square inch of Earth's surface are being continuously bombarded by neutrinos from space. Billions of neutrinos slice through your body every second. Fortunately, neutrinos are so unlikely to interact with any matter including the atoms and molecules in the human body that the billions upon billions of neutrinos that hit you every second have no discernible effect at all. In fact, the odds that any neutrino striking Earth will interact with any atom in our planet at all is about 1 in a billion. Even when it does happen, the result is merely a tiny flash of harmless light.
What mineral were scientists surprised to see in high quantities in the stratosphere?
Scientists discovered a higher than expected amount of salt in the mesosphere within the stratosphere. The current theory is that the salt has been left behind by meteor activity. The tropopause is the layer between the troposphere and the stratosphere that hovers around 10 miles. 16 kilometers, above the ground. Within the tropopause is the tropopause break, a region through which water vapor and air can easily pass from the troposphere to the stratosphere.
What is heat exhaustion?
When the temperature is too high and people do not drink enough fluids, exert themselves too much, or spend too much time in the direct sunlight, heat exhaustion can result. Symptoms can include weakness, cold and clammy skin, paleness, fainting, irregular heartbeat, and vomiting. In extreme cases, heat exhaustion has been known to kill. There have been a number of cases where people exercising at a sports practice or conducting drills in the military have collapsed and died. Seniors and people who are already ill are particularly susceptible to heat exhaustion.
What is albedo?
Albedo is the amount of the sun's energy that is reflected back from the surface of the Earth. Overall, about 33% of the sun's energy bounces off the Earth and its atmosphere and travels back into space. Albedo is usually expressed as a percentage.
What is the doctor?
This is an affectionate term, used in places such as the Caribbean, referring to the cool, refreshing sea breezes that make a hot day more bearable.
What was the first university to offer a degree in meteorology in the United States?
The Massachusetts Institute of Technology was the first institute of higher education to offer a meteorology degree. Swedish meteorologist Carl Gustav Rossby, 1898 to 1957, founded the program there in 1928. Rossby would go on to found programs at the University of California at Los Angeles and the University of Chicago, as well.
Who introduced use of the millibar to measure air pressure?
English meteorologist William Napier Shaw, 1854 to 1945, was one of the leading scientists in his field, and former director of Britain's Meteorological Office from 1905 to 1920. He suggested that air pressure be measured in millibars in 1909. But it was not adopted as an international standard until 1929.
What is a heat wave?
A heat wave is a period of 2 or more days in a row when apparent temperatures on the National Weather Service heat index exceed 105 degrees Fahrenheit to 110 degrees Fahrenheit, 40 degrees Celsius to 43 degrees Celsius. The temperature standards vary greatly for different locales. Heat waves can be extremely dangerous. According to the National Weather Service, 175 to 200 Americans die from heat in an average summer. Between 1936 and 1975, as many as 15,000 Americans died from problems related to heat. In 1980, 1,250 people died during a brutal heat wave in the Midwest. In 1995, more than 700 people died in the city of Chicago from heat-related problems. A majority of these individuals were the elderly living in high-rise apartment buildings without proper air conditioning. Large concentrations of buildings, parking lots, and roads create an urban heat island in cities.
How strong is Earth's magnetic field?
On typical human scales, it is pretty weak. At Earth's surface, it is about 1 Gauss in most places. A refrigerator magnet is typically 10 to 100 Gauss. However, the energy in a magnetic field depends strongly on its volume. So since the field is bigger than our entire planet, overall, Earth's magnetic power is formidable.
What is the thermocline?
Imagine the water in a sea or ocean as being similar to very dense air in the atmosphere. Just like with the air, layers of water can have different temperatures and pressures, with warm waters generally being on top of colder layers of water. The difference between the temperatures in these layers is called the thermocline.
What is the current extent of deforestation?
Worldwide, we are losing enough forest land annually to cover an area the size of the state of Panama. To put that figure into numbers, that is a net loss of 7.3 million hectares, 18 million acres, every year. Actually, about 13 million hectares, 32 million acres, are being chopped down yearly. But there are restoration projects going on that help replant forests. This rate of loss, which is an average taken from the years 2000 through 2005, is somewhat better than the 8.9 million hectare, 22 million acre, loss that was experienced during the previous decade. Although replanting is great, new forest growth does not make for as healthy a habitat for wildlife as old forest growth.
Who first theorized that human activities were causing climate change?
The Swedish scientists Svante August Arrhenius, 1859 to 1927. Who was one of the founders of the discipline of physical chemistry, is sometimes credited as the first person to discuss in detail the effects of carbon dioxide, CO2, on Earth's climate. Arrhenius came upon his theory while studying past ice ages, and in 1896 published a paper in which he proposed that ice ages occur when CO2 levels go down. By his estimates, doubling CO2 amounts would increase average world temperatures by about 2.5 degrees Fahrenheit, 5 degrees Celsius, and having the levels of this gas would have the opposite effect. Recent modeling studies come quite close to Arrhenius's original estimate. Unlike today's environmentalists and climatologists, however, the Swedish scientist believed that global warming would be a good thing for two reasons. It would help prevent another ice age and it would aid in crop production to feed a hungry world.
Where do cosmic rays come from?
A continuous stream of electrically charged particles flows from the sun. This flow is called the solar wind. It makes sense that some fraction of cosmic rays originate from the sun. But the sun alone cannot account for the total flux of cosmic rays onto Earth's surface. The source for the rest of these cosmic rays remains mysterious. Distant supernova explosions could account for some of them. Another possibility is that many cosmic rays are charged particles that have been accelerated to enormous speeds by interstellar magnetic fields.